Dear students, welcome to my channel EEC. I am Dr. P. Suresh. Today we are going to discuss regarding a power system. So in the overview of the power system topics, what is a power system? We are going to discuss what is the power system, and we are going to discuss single line diagram of a power system, different types of transmission systems, transmission line parameters, and calculation of line parameters. And also we are going to solve a problem, numerical problem regarding calculation of line parameter. So before going to solving the problem, we should know what is a power system. So before that, what is electrical power and how it is generated. So actually the introduction for electrical power. So electrical power is one of the most versatile form of energy, so which is used almost in every aspect of modern life. So it can be easily generated, transmitted, and then distributed over a longer distances. So and also we can control the electrical power, and it can be utilized. Now, if you see the applications of electrical power, it is used almost all over all the applications. So it is used in domestic application like lighting, heating, cooling, cooking. You can also rotate fans, like household appliances, refrigerator, etc., etc. And also it is used for industrial applications, agricultural applications, commercial applications, and in communication systems you can use that, right? So how the electrical power is generated, and what are the components used for generation of electrical power. So it starts with the power system. So what is a power system? So if you see the power system is a complex system which is going to be comprising of a generating station, transmission system, and then distribution system. Actually we are utilizing the electrical power, but the power should be generated, electrical power should be generated. So it is generated in a generating station, and once it is generated, it is going to be transmitted, and after transmission it is utilized. So the utilization is done by the distribution system. So there are three systems: generating system, transmission system, and then distribution system. So the comprising of all the three systems, it is called as a power system. Simply we can call as generation G, transmission T, and then distribution D. So GTD. So using generation, transmission, distribution, we can generate power, and we can use the power, right? So first we will take what is the generating station. So generating station is nothing but it is the place where the electrical power is generated. So for generating electrical power, we require a generator. So generator is important. So generator, and also the generator, it does not operate by itself, or it does not rotate by itself. So it requires a prime mover. The prime mover is required. So once the prime mover is rotated and the prime mover is coupled to the generator rotates, and then it is going to generate the electrical power. And how the prime mover is rotated, so that is important. So for generating, for rotating the prime mover, so we have in need of resources. Some resources are required. So based on the resources available, so we can use the resources, and we can rotate the prime mover, and we can generate the electrical power, right? So if you take the resources, we have conventional energy resources and non-conventional energy resources, conventional and then non-conventional. So if you go for the conventional energy resources, we have coal, we have diesel, and then we have gas. So using these resources, we can use these resources, and we can make the prime mover to rotate, and once the prime mover is rotated, the generator is going to be rotated, because we know what is the principle of operation of a generator. So generator is nothing but it is the device which is used to convert mechanical energy into electrical energy. So mechanical form into electrical form. So mechanical form here, it is nothing but a rotating energy, rotating force. So the rotating force is given by prime mover. So the rotation of prime mover is created by the resources like coal, diesel, gas, etc. And also we can go for generating the power using non-conventional energy resources. The other name for conventional energy resources is nothing but non-renewable energy resources. So these are all the non-renewable energy resources. And coming to non-conventional energy resources, we have solar energy, wind energy, tidal energy. So using these energy resources, we can generate the power. So on the whole, generating station is nothing but the place where the electrical power is generated. So it is called as generating station. Okay. And something that if you take any generator, the maximum amount of voltage that can be generated by a generator is of 11 kilovolt. So this is the normal generating voltage. Okay. So once the voltage is once the power is electrical power is generated, so it should be transmitted. So the transmission system is coming to picture. So the power is generated. Actually, where the power is generated, where the ample amount of resources are available. All the resources are available in the remote area. So the power is generated using those resources, and the power is to be transmitted. So for transmitting the power, we have to go for another system that is called as transmission system. So under a transmission system, we have two different types of systems available transmission. So we can go for AC transmission system, we can go for DC transmission system. There are two different types. So using any one of the types of transmission, we can transport the power from one place to other place. And comes to the third one called as distribution system. So in this distribution system, the power is to be distributed among the consumers. So we are having different types of consumers. So the consumers can be classified as like your domestic consumer. So domestic consumers and industrial consumers. So industrial consumers, and we can go for commercial consumers. So using the distribution system, we can give the power among the consumers. So domestic, industrial consumer, and commercial consumer. Right. So this is how the power is generated, transmitted, and distributed. But what is the main objective of the power system? So it is just not giving the power to the consumers, but it should obey some rule. So the objective of power system is it should give a quality power. So quality power to the consumer. So what is the meaning for quality power? So quality power is the sense is nothing but giving the constant voltage and constant frequency. These two things are to be maintained whenever we are giving AC power. So voltage and frequency should be maintained. So when there is a variation of voltage and frequency, the appliances connected with the power system will be suffering or will malfunction. So voltage and frequency should be maintained. So when these two parameters are maintained, we can call this the quality power. So the objective of power system is to give your quality power to the consumers. So quality power is nothing but maintaining the voltage and frequency as a constant parameter. So this is the power system, and you can see this is the block diagram of a power system. We can see here. So this is the place where we can go for generation. So this is nothing but generation. So the power is generated here, and once the power is generated, it is going to be transmitted. So this is nothing but transmission system. So it is given to transmission system, and once it is transmitted, then we are going for distribution system. So this is called as the distribution system. So generation, transmission, and distribution. So this is the power generating station. This is power generating station, and this is nothing but transmission system, and then the third one is nothing but the distribution system. So you can see here the power is distributed among the consumers. We have the domestic consumer here. So this is the domestic consumer. We can have the commercial consumers, and we can have the industrial consumers. So this is the scenario of how the power is generated, transmitted, and distributed. Now we will see the single line diagram of a power system. So if you take a power system, So if I take a power system, I can draw a single line diagram or one line diagram. You can call a single line diagram, simply called as SLD, or it can be called as OLD, one line diagram. So as you know that a power system is consisting of three parameters, three things like generation, transmission, distribution. So I can take generation like this. So this is nothing but referring the generation. So this is giving to the transmission system. So this is transmission system, and it gives the power to the consumers. So this is nothing but the distribution system. So generation, transmission and distribution. So this type of arrangement of combining all the three systems, it is called as the power system, single line diagram of a power system. And this single line diagram can descriptively given here. Okay, so it is given here. So the first one, it is nothing but the generating station. So this is nothing but generating station, and second thing, from here to here, it is called as the transmission system. So this is transmission system, and the third one, it is nothing but the distribution system. So it is given in an elaborate way: generation, transmission and distribution. So you can see here, this is the generator. So you can see this is the generator. So using the generator, we can generate the power. So this is the generator, So this generator is going to generate 11 kV. 11 kV. This is the generator, and this generator is generating the power, and the power is to be transmitted for the longer distance. Right. So using the transmission system and distribution system. Right. So while the power is transported for a longer distances, it makes more amount of losses. So the loss is created by the current. Okay. So we know the formula for power. Power is equal to V into I, and also power is constant. Whenever I want to reduce the power loss which is going to happen in the system, the formula for power loss, it is I square R. So in order to reduce the power loss, the only way I can reduce the current. So once the current is reduced, the power loss can be reduced. So in order to reduce the power loss, I can increase the voltage. If the voltage is increased, by default the current is reduced. The reason is, we can see here, we know the formula for power. Power is nothing but P is equal to V into I. So power is constant. So this is constant one. So whenever the voltage is increased, then the current is reduced. So the formula for power loss is nothing but which is equal to I square R. I square R. So here R is constant. So in order to minimize the loss, I have to reduce the current. So if I want to reduce the current, I have to increase the voltage, because power is constant. So one parameter is increased, then another parameter reduces. So I need to reduce the current. So in order to reduce the current, I have to increase the voltage. For increasing the voltage, I have to connect a transformer. So this is the transformer. So this is a step-up transformer. We can see here, we are generating 11 kV. This 11 kV is increased to 220 kilovolt. 11 kV to 220 kilovolt. So enormous amount of voltage is increased. So obviously the current is getting reduced. So this is the transformer. So we can see this is the transformer. This transformer is also called as power transformer. Power transformer. So if you take any power system, this is the only transformer which is going to increase the voltage, or it is the step-up transformer. All other transformers connected in the power systems are step-down transformers. Okay, so now we are connecting a transformer. It is going to increase the voltage. Now we are going to transport the power. So transportation system or transmission system. So we are having two different types of transmission system. One is called as primary transmission, and second is called as secondary transmission. So in order to have the primary transmission system, we are having a transmission corridor here. So this is the transmission corridor. So the transmission, as I told you earlier, the transmission can happen using AC transmission or DC transmission, overhead transmission or underground transmission. So we can use any mode of transportation. So you can see here, this is the primary transmission. So the power is transported from one place to other place using a primary transmission system. So under primary transmission system, the voltage level is maintained at 220 kilovolt. Now we are going for secondary transmission. So for getting the secondary transmission, now we are going to reduce the voltage. So for reducing the voltage, we are going for step down transformer. So we are having a step down transformer here. So here this step down transformer reduces the voltage from 220 kilovolt to 33 kilovolt. So it is going to reduce. So now after reduction of voltage, again the transmission corridor transmits the power. So that is done by transmission system or secondary transmission system. Now the power is generated, transported. So transmission system is over. Now we are going to distribute the power. In order to distribute the power, we are going to distribute the power among the consumers. Some consumer they require higher voltage, some consumer they require lower voltage. So based on the consumers, we are going to reduce the voltage. So we are going to distribute the voltage. So for that case, we are going for primary distribution, and second is called as secondary distribution. So again, for primary distribution system, we are going to reduce the voltage from 33 kilovolt to 66.6 kilovolt, because this consumer requires slightly less amount of voltage, so 6.6 kV. Now some other consumers are there, like domestic consumers, so they require sometimes normally 400 volt or 230 volt. So normally 400 volt it is mentioned as 3-phase voltage, and 230 volt it is mentioned as single phase voltage. So for domestic consumers, some consumers require 230 volt, some consumers require 400 volt. So now this 6.6 kV is reduced to 400 volt or 230 volt, and then the power is distributed, so using the second distribution system. So this is how the power is generated, transported, and then distributed among the consumers. So this is the detailed diagram of a power system. So this one, on the right side one, this one is giving you the single line diagram. So this one is giving you the detailed arrangement of components or detailed structure of the power system. Okay. So next we will see what are the different types of transmission system. So we are going to concentrate only on different types of transmission systems. Okay, so if you take the transmission system, so the transmission can happen using a single phase circuit, or it can happen a 3-phase circuit. So before that, what is a single phase circuit, what is single phase system, what is 3-phase system? So if you take a power system, so the power system is having 3 phases. So it is having 3 phases like this. So R phase, Y phase, and then B phase, RYB. So this is the transmission conductor, and also it is having one more conductor called as neutral. So R phase, Y phase, B phase, and neutral. Okay. So when I want a single phase circuit, a single phase system, so single phase system is nothing but we require 230 volt like that. Okay, 230 volt. So for making the single phase system, I have to take any one of the phases to the neutral. I need any one phase that can be connected to the neutral. If I take the voltage, if I measure the voltage between any one of the phases to the neutral, it is called as a single phase system. So for this case, I require only 2 conductors. So this is one conductor, this is another conductor. So this is phase conductor and this is neutral conductor. The voltage between these 2 conductors will be 230 volt, and the frequency, it is 50 Hz in India. So this is called a single phase circuit. So for a single phase circuit, we require 2 conductors. So for phase, 1 conductor, neutral, second conductor. So 2 conductors are required. On the other hand, if you go for a 3-phase circuit, so 3-phase circuit is nothing but we require all the 3 phases. So I can go for a 3-phase circuit like this. So this is a 3-phase circuit. So this is R phase, Y phase, and B phase. And similarly, if you measure the voltage between R and Y, so that is going to give 440 volt, it is a 3-phase system. And similarly, if you measure the voltage between Y and B, again it is also 440. And if you measure the voltage between R and B, so R and B, so that is also 440 volt. So here we require 3 conductors. we require 3 conductors. For single phase system, we require 2 conductors. So I can use single phase circuit or 3 phase circuit. Mostly for transmission system, we can use a 3 phase circuit for transmission purpose. For distribution purpose, we can go for either single phase circuit or a 3 phase circuit, right? And also we can have the classification of a 3 phase circuit. So the classification of 3 phase circuit, we can have a star connected circuit, a star connected system, and a delta connected system. As we know that star connected system, this is the star connected system. So under this case we have 3 phases, R phase and Y phase and then B phase, like red, yellow and then blue. So there are 3 conductors. So for R phase, this is the starting point and this is end point, starting point, end point. Similarly for Y phase, this is starting point, end point, and B phase, it is starting point, end point. And you can see the structure here, all the end points are connected at this point for all the 3 phases. So that makes a neutral point. So this is called as a star connected system. And the second one, we can have the delta connected system. So delta connected system, if you take the R phase, so this is the R phase conductor, this is starting point and this is end point of the coil. And similarly for Y phase, this is starting point of the coil, this is the end point of coil. And similarly V phase, starting point of the coil, end point of the coil. You can see here, the end point of the first coil is connected to starting point of second coil. Similarly, end point is connected to starting point. So when the starting point is connected to end point, then we can have a delta connected system. So again we can see here there are 3 phases. This is R phase, this is Y phase and this is B phase. And similarly you can hear R phase, Y phase and then B phase. So connecting all the 3 conductors like this is called as star connected system. On the right hand side you can see this is called as delta connected system. So there are 2 different types of arrangements. So whenever we want to transmit the power, from one place to other place, then we have to go for delta connected system. For distribute the power, we have to go for a star connected system, because when you go for a star connected system, I can take both a single phase circuit as well as a 3 phase circuit, because for a single phase circuit I require neutral. So only in star connected system I can find the neutral, but not in the delta connected system. So delta connected system is useful for transmitting the power from one place to other place, because for just transmitting the power there is no need of the neutral point. So that is why we are going for delta connected system. And also the main advantage of going for delta connected system is we can reduce the number of conductors. So if you take the star connected system, if I want to transmit the power using the star connected system, I required 4 number of conductors, because R, Y, B and neutral 4. Okay, but in terms of delta connected system I require only 3 conductors, R, Y and B. So in order to reduce the cost of the conductor for transmitting the power, I can go for delta connected, but that is not the case for a star connected system. That is only for distributing the power. And also we can also have the classification among the 3 phase circuit, okay, into symmetrical, unsymmetrical, transposed and transposed. So how the classification is made? For instance, if I take the symmetrical system, if I go for a 3 phase system, I require 3 conductors. So R conductor, Y conductor, B conductor. So R, Y and then B. So I need 3 conductors like this. For a symmetrical system, the distance between R conductor and Y conductor, and R and B and Y and B, okay, so all the distances between the 3 conductors are equal. Then that type of arrangement of transmitting the power or transmission system is called as symmetrical system. This is called as symmetrical. Why it is called as symmetrical? Because the distances are equal. On the other hand, if I go for an unsymmetrical system, then I can go for, this is R phase conductor, this is Y phase conductor, and B phase conductor is here. So this is B phase. You can see the distance here. So the distance is varying. So this is called as unsymmetrical system. Unsymmetrical system. So symmetrical system is nothing but the distance between the conductors arranged in the transmission system. It is called symmetrical. And coming to unsymmetrical system, the conductors are having difference in length. And then coming to transposed system. So transposed system is nothing but changing the position of conductor in a transmission corridor. Okay, you can see here. So this is R phase, this is Y phase, and this is B phase. There are three conductors R, Y, B. I am talking about transposed system. So this is the transposed system R, Y, B. We can see here the R phase conductor is running for a certain distance R, Y, B. After a particular distance is reached, the position of conductor is changed. You can see here R, Y, B, and then the topmost conductor initially it was R, middle is Y, bottom is B. After some distance, the B conductor comes to the top, and R comes to the middle, and Y comes to the bottom. Now after some distance, again you can see here YBR. So this is some arrangement of conductor. So this arrangement of conductor is called as the transposed system. And coming to untransposed system, for untransposed system there is no change in the conductors. So when the conductor is running for a particular distance, there is no change in the position. So R, Y, and then B. It is not going to be changed. Okay. So there are different types of three-phase circuit: symmetrical, unsymmetrical, transposed, and then untransposed. So these are the different types of systems available in the power system. Using this, we can transport the power. So among all these three-phase circuit, symmetrical, unsymmetrical, transposed, untransposed, we can also transmit the power using DC transmission. So DC transmission is also available. So for DC transmission system, we require only two conductors, plus conductor and minus conductor, or positive conductor and negative conductor. So positive conductor, negative conductor. So only two conductors are required. So using AC transmission system, we can transport power. Using DC transmission system, we can transport power. Okay, so these are different types of transmission systems available. And you can see here, these are all the transmission towers which are available for transporting power. If you take the first case, okay, if you take the first case, you can see here, we can run only two conductors. So it is, this is, I can also take this as phase and neutral. So this is for single phase system. So phase and neutral. And for the second case, you can see here, for the second case, you can see I can place three conductors, R, Y, and then B. So this is R conductor, this is Y conductor, and this is B conductor. And also I can also tell that, so this is nothing but unsymmetrical system, because this is R phase, this is Y phase, and this is B phase. So we can see the distances are differing. So this is called as unsymmetrical system. And also we can see this case. If we take this case, so this is R phase, and this is Y phase, and this is B phase, R, Y, B. This is also called as unsymmetrical system because the distance between the conductors are differing. Okay, and we can see here, so this is R conductor, this is Y conductor, B conductor. So this is R, Y, and B. Again at the right side you can see here three conductors can be placed. So this is R, Y, B. So this type of arrangement, this type of arrangement is called as single circuit. Three-phase single circuit. So this type of arrangement, it is called as double circuit. So what is the meaning for double circuit? With the help of only one transmission tower, I can place two circuits. So this is one circuit and this is another circuit. So two circuits can be formed. Okay. So this is the arrangement of towers by which the conductors are placed on the transmission tower for transporting the power from one place to other place. So these things you can see in the roadsides. Okay. So different types of arrangement of towers are shown here. Okay. And if you take the transmission line, so the transmission line is nothing but the transmission line is made up of either copper or aluminum. So copper or aluminum. Okay, so the conductors are made up of copper or aluminum. So when you take copper and aluminum for transmitting the power from one place to other place, some line parameters, transmission line parameters. So if you take the transmission line, so this is made up of either copper or aluminum. So this is R phase, Y phase, B phase. You know, all the three conductors will be having some parameters. We are calling as line parameters. So those parameters are nothing but resistance. Second one is inductance, and third one is capacitance. Resistance, you know, resistance is nothing but it is the character of a component which is going to resist the or oppose the flow of current. Resistance. Same way inductance. So inductance is also going to resist the or oppose the flow of current, but then there is a change in current. And similarly capacitance, it is also going to oppose the current and there is change in voltage. So all these three parameters are available in the conductor. If you take copper, you can find RLC. If you take aluminum, again you can find RLC. And also all these three parameters, resistance, inductance and capacitance, all these three parameters are uniformly distributed over the transmission line. Uniformly distributed. Okay. So when you measure the resistance value, inductance value and capacitance value, those values are uniformly distributed from starting point to end point. So using all these three parameters, resistance, inductance, capacitance, we can form the transmission line, or we can create the equivalent circuit for the transmission line. Okay. So you can see the diagram here. So this is resistance R, this is inductance L, and this is capacitance. Normally, resistance is connected in series, inductance is connected in series, but capacitor should be connected in parallel. So this is RLC, and also this is the starting point of the corridor, transmission corridor, and this is your end point of the transmission corridor. Okay, for all the till the end of the transmission corridor, we can see R, L, and then C, R, L, and then C. Okay, so all these parameters are uniformly distributed among the transmission corridor. Okay, so we can also find the value of resistance, we can calculate the value of resistance, we can calculate the value of inductance, we can calculate the value of capacitance. Okay, so what is the need for calculating the value of R, L, and C? Okay. So if you take the resistance, the first one, resistance, inductance and capacitance, all these three parameters are going to make an impact over the power system. Okay. So how it is going to make impact? If we take the power transmission line, one of the major components of electrical power system, it is its major function is to transport electrical energy. We know that. So if you transport the power from one point to another point, it makes losses. It makes losses. We know the loss is nothing but, so we can have the loss by formula I square R. I square R is nothing but loss, power loss. So for this case, resistance is included, or resistance plays a vital role. And similarly, sometimes there is a voltage drop in voltage. So this drop in voltage can be created by resistance, can be created by inductance, or it sometimes can be created by capacitance. Okay. So resistance, inductance and capacitance, they are going to make an impact over the power system. Okay. So how they are going to make? So if you take the series resistance, so series resistance makes the power loss. So in order to reduce the power loss, we have to calculate the resistance value. And also resistance makes the voltage drop, because the formula for voltage drop V is equal to I into R. I into R. This is nothing but voltage drop. So for drop in voltage, calculation of drop in voltage, for power loss, we need what is the resistance value. So once the resistance value is known, we can find what is the voltage drop, what is the power loss. And the series inductance, so that is essential for voltage drop calculation, and also for shunt capacitance, this is also used for calculation of voltage drop. So if we take the resistance, it is used for power loss calculation and voltage drop, and inductance and capacitance, it is essential for voltage drop calculation and capacitance is also for voltage drop calculation. Okay, if you take the inductance and capacitance, so how the inductance and capacitance are created or formed in the transmission line. So resistance is nothing but resistance, it is always there in any conductor, but inductance and capacitance, they are produced or created by the presence of magnetic field, and capacitance is created by electric field. When there is change in magnetic field, the inductance is going to change. When there is a change in electric field, then the capacitance is going to be changed. Okay. So for these reasons we are going to calculate RLC values. After finding the RLC values, what is the use, what is the application of, what is the necessity for calculating or finding the value of RLC? So in order to find the efficiency and voltage regulation. So if you take any system, like this, we are going to give some input power, we are going to give some input power, we are going to get output power, but we know something, only for ideal system input power is equal to output power, but for other systems the two powers are not equal because of losses. So in order to calculate the efficiency is nothing but output by input, efficiency is nothing but output by input. Now normally it is mentioned as percentage, so it should be multiplied by 100. Okay, so in order to find the input power, in order to find the output power, we require the losses, because output is nothing but input minus losses, or input is equal to output plus loss. So for finding the losses, I need the resistance value. So once the resistance value is found, I can find the loss and I can find the efficiency. So normally for the transmission system, we are going to calculate, the regulation. So regulation is nothing but change in voltage. What is the voltage change available in the transmission corridor? Okay, so the formula is given as Vs minus Vr by Vr. So Vs is nothing but sending end voltage. Vr is nothing but receiving end voltage. So sending end voltage Vs, receiving end voltage Vr. So the ratio between change in voltage to the receiving end voltage into 100, then gives the voltage equation. Similarly, for transmission efficiency, we can find the efficiency here. So it is nothing but receiving end power, that is output power, receiving end power by sending end power. So the formula is given. Actually, for the formula for power is nothing but Vi cos phi. So that is the formula for power. Vi cos phi is the formula for power. But in order to find the power at the receiving end, we are going to use the letter R, VR, IR, cos phi R. So VR is nothing but receiving end voltage, IR is nothing but receiving end current, cos phi R is nothing but the power factor. Okay, and similarly, input power is nothing but sending end power. So sending end power is calculated using Vs, Is, cos phi S. So using these formula, we can calculate transmission efficiency and voltage regulation. So this is the reason why we are calculating R, L and C values. Okay. So how the resistance is calculated? So we know what is the formula for resistance. So resistance is equal to rho L by A. Okay, rho L by A. So rho is nothing but it is the resistivity of a material. Resistivity is rho, and A is nothing but area of cross section. A is area of cross section, and L is nothing but the length. So once all the three parameters are known, rho L by A, then we can easily calculate the resistance value. Okay. And coming to the calculation of inductance. So inductance is nothing but it is defined as flux linkage to the current. Normally flux linkage is denoted by psi and current is denoted by I. Okay, so psi by I, flux linkage to the current. Psi by I is nothing but the inductance. So what is the meaning for flux linkage? So flux linkage in a conductor involves in the interaction of magnetic flux with the current. Whenever the magnetic flux and current are interacted, that gives the flux linkage. Once the flux linkage is known and the current is known, we can find the inductance. Okay, so the formula is given here. So L is equal to psi by I, and also psi is calculated by L into I. Okay. So this is how the inductance value can be calculated, and some of the formulas are given. Okay, how the inductance value can be calculated. So there are different types of arrangement of conductors, as I told earlier. A single phase system, three phase system. Under three phase system we have symmetrical, unsymmetrical, single circuit, double circuit, transposed, untransposed. So there are different types of arrangement of conductors. So whenever there is a change in arrangement of conductor, then the magnetic field is changing. So once the magnetic field is changing, then the inductance value is going to be changed. Okay. So based on the arrangement of conductors, we can have the formula here. So if we take the single phase system, single phase line, the inductance per conductor per meter. So we are going to calculate the inductance per meter. So normally inductance is denoted by henries. So henries per meter. So inductance for one conductor per conductor for 1 meter. So which is given as 2 into 10 power minus 7 log E dm by ds. So normally the generalized formula we can have 2 into 10 power minus 7 natural log E d by r. D by r. So if you take the conductor, single phase conductor like this. So this is phase and neutral. So this is phase and neutral. The conductor is having, this is the conductor, circular conductor. So it is having a radius. So the radius is denoted by d. And then the distance between the conductors. So this is the distance between two conductors. The midpoint to the midpoint. Midpoint to the midpoint. It is denoted by the distance d. Once the radius and the distance are known, we can easily find the inductance using this formula. So 2 into 10 power minus 7 log E d by r. Okay, so this is for solid conductor. So whenever we go for hollow conductor, we have to use this formula. So we have to use this formula. So inductance per conductor per meter equal to 2 into 10 power minus 7 log E dm by ds. Or otherwise, we can use this formula 10 power minus 7 1 plus 4 log E d by r. Okay. So normally, if you take a solid conductor is nothing but this is like solid conductor. So this is solid conductor. So for solid conductor, we have to take the radius as r itself. Radius is nothing but the distance between center point to the surface. So that is nothing but r. But we can use the hollow conductor. So hollow conductor is nothing but this is the conductor, this is the circular conductor. But in the circular conductor, the element, the component is not there at the center. So it is a hollow. Okay. So if I want to find the radius for the first case, I can easily find the radius. But for the second case, I cannot find the radius easily. So they found the radius as r dash. Radius is nothing but it is 0.7788 times the radius. So this is for hollow conductor. So whenever we are using a solid conductor, we have to use this formula. And similarly, whenever we are going to use a hollow conductor, we have to use the first formula. So this is the formula for single phase line. And here it is denoted as dm and ds. Okay. So dm is nothing but mutual distance. Later we will see what is dm. And ds is nothing but self distance. Self and mutual. Okay. So ds by dm. Using this formula, we can find the single phase inductance for a single phase system. And similarly for a three phase system, again the formula is same. But in order to calculate dm, there is a formula. Dm equal to d1 d2 d3 whole power 1 by 3. So dm is nothing but mutual distance. What is the mutual distance between two conductors? So if we take three conductors like this, I can take the distances. As d1, d2 and d3. I need to find what is the equilateral distance between the conductors. So that is nothing but dm, and ds is nothing but self distance. Okay. So normally self distance is nothing but the distance only in the conductor, but dm is nothing but mutual distance between conductors, two conductors. Okay, or three conductors. So it is given as ds equal to 0.7788 r, or dm is equal to d1 d2 d3 whole power 1 by 3. And for the third case, for the double circuit line, again it is also given as 2 into 10 power minus 7 log E dm by ds. The formula is same, but calculation of dm is differing, or ds is differing here. Okay, so for this case, ds is equal to ds1 ds2 ds3 whole power 1 by 3, and dm equal to dab dbc dca whole power 1 by 3. Okay, so later we'll see what is dm, what is ds. Okay, right. So these are the formula for finding the inductance values, and similarly for capacitance values. We can also calculate the capacitance value. So capacitance for a single phase system. So single phase system or two wire system. So this is two wire system. There are two wires. For calculating this is wire number 1, wire number 2. Okay, we can take connector A and connector B. Okay, we can calculate the capacitance. So CAB is equal to pi epsilon naught divided by log E d by r. Again, d is the distance, r is the radius. Okay, and similarly we can also find the capacitance for two conductors that is connected between phase and neutral. So capacitance to the neutral, it is 2 pi epsilon naught log E d by r. So only differing, the 2 is differing here between these two. Okay, and for three phase system, again it is 2 pi epsilon naught log E d by r. And for unsymmetrical spacing, for the previous one is symmetrical spacing, for unsymmetrical spacing the formula is 2 pi epsilon naught divided by log E and the cube root d1 d2 d3 by r. So using this formula we can calculate the capacitance value. Okay, right. So next we will see, we will take a problem, so that is going to give you how the inductance can be calculated. So the problem is given here. You can see this is an example problem number 1. So it is given as a single phase line has two parallel conductors 2 meters apart. The diameter of each conductor is 1.2 centimeter. Calculate the loop inductance per kilometer of the line. So the parameters are given. So what are the parameters given to you? So what are the parameters, or what are the data given to you? So given, so a single phase line has two parallel conductors. There are single phase line, there are two parallel conductors like this. Okay, so this is like A and B. There are two conductors. What is the distance between two conductors? It is separated by 2 meters. So from center to center the distance is 2 meters. The diameter of each conductor, so the diameter is given. So diameter is given as is 1.2 centimeter. 1.2 centimeter. So given R is given as D is given as diameter. Diameter is given as 1.2 centimeter, and the distance is given as 2 meter. So these are the two data given. So what is you are going to find? We are going to find inductance value. So what is the formula for inductance value? L is equal to, the formula is given as 10 power minus 7 into 1 plus 4 log E d by r. This is the formula. So in order to find the value of d and r, you can see here the diameter is given in terms of centimeter and the distance is given in terms of meter. So I can convert both the things in centimeter. Okay, so the distance is given as 2 meter, which is nothing but 200 centimeter, and the diameter is given as 1.2 centimeter, which is nothing but r is nothing but 1.2 by 2, which is equal to 0.6 centimeter. So now we know what is d, what is r. We can substitute the value here, so which is equal to 10 power minus 7 into 1 plus 4 log E natural log. So the d value is 200 by r value is 0.6. So this much henries per meter. Okay, so after calculating, the L value is given as, found as 24.23 into 10 power minus 7 henries per meter. So this is L value, but we need to find what is the inductance per kilometer. So inductance per kilometer, for finding the inductance per kilometer we have to multiply with the 1000. So into 10 power minus 7 into 1000. This much henries per meter. So which is coming around 24.23 into 10 power minus 4 henries per meter. Or I can also take the inductance per kilometer value as 2.423 millihenries. So whenever two conductors are separated by 2 meters and the radius or the diameter of the conductor is given as 1.2 centimeter, then the inductance of the transmission line for 1 kilometer, it is 2.423 millihenries. So this much amount of inductance is available. So once the inductance value is calculated, we can easily find what is the voltage drop. Okay, so this is how we have to solve the problem. Okay, I hope you can understand what is power system, what is line parameter, how we can calculate resistance, inductance and capacitance, and you can understand the problem. Okay, thank you.